Hey guys, we are back with the past papers practice for the particle nature of matter, which is also called as kinetic particle theory, and some other questions related to apparatus. Okay, so we have done this question number 1B part in the previous video. Right now, we are going to solve question number 1B part 2. The following apparatus, I am going to spotlight it. Okay. The following apparatus can be used to measure the rate of diffusion of a gas. It is a constant pressure applied here. So it is a metal foil. Gas escapes through small holes in the foil. Okay, small holes in the foil. Okay, done. Small hole. This is a small hole over there. So this is a gas syringe and this is the gas over there. Okay. So nitrogen is there, 25 temperature, 25 temperature, and this is nitrogen 50 temperature. Rate of diffusion, it is observed that rate of diffusion and nitrogen 25, same temperature was applied for nitrogen and chlorine, but chlorine diffuse very lesser as compared to nitrogen. Okay, if you are looking into the symbol of nitrogen, how it is written in the periodic table, it is like this 714, whereas what about the chlorine? It is written like this 1735.5. Okay, we can say this thing that nitrogen is having a mass of 14, whereas chlorine having a mass of 35.5. If we are going to write the formula of nitrogen, it will be N2, whereas the formula of chlorine will be Cl2. Okay. Why nitrogen will be N2 and why chlorine will be Cl2? This story I am going to tell you when I will teach you the chapter of bonding. But right now, I'm just telling you that nitrogen and chlorine both are diatomic. What is this diatomic terms telling you? Diatomic. I'm writing here as well, diatomic. What is the meaning of diatomic? It means that two atoms of an element are combined together. Okay. So there is a statement which I will suggest you to keep that in your mind. All right. So all the elements of group number 7, oxygen, nitrogen, and hydrogen are naturally diatomic. So what are the elements of group number 7? Fluorine, chlorine, bromine, iodine, astatine. Okay. Astatine symbol At. Fluorine is not Fl, I have told in the previous video as well. So all these elements along with oxygen, nitrogen and hydrogen, these are all naturally diatomic. So we have to consider them N2, F2, Cl2, Br2, etc. So what is the mass of N2? It will be 14 plus 14, it will be 28. What will be the mass of chlorine? 35.5 plus 35.5, it will be 71. Okay. So we can say this thing that rate of diffusion for chlorine is much lesser as compared to the rate of diffusion for nitrogen, whereas the rate of diffusion for nitrogen is increasing when temperature is increased to 50 degrees Celsius. All right. Explain why nitrogen diffuses faster than chlorine. What is the answer? We have discussed this thing in case of diffusion. When I have taught you diffusion earlier, I have told you that diffusion is based upon two of the factors. One of them is temperature, whereas the other of them is relative molecular mass. MR stands for relative molecular mass. What is the meaning of relative molecular mass? It is a compared value. Carbon is taken as standard. 1/12 of carbon 12 is taken as standard. Let me explain this thing to you. 1/12 of carbon 12 is taken as standard. And all the masses of all the elements in the periodic table are compared with that of carbon 12. 1/12 of carbon 12. So that's why the term of relative is used. I will tell you the exact definition of MR and AR. AR stands for relative atomic mass when it is the mass of an atom of an element, and MR stands for relative molecular mass when it is mass of more than one atom of the similar element or the different element combination. So if it is Cl2, it will be considered as MR. If it is only Cl, it will be considered as AR. Okay. Explain why nitrogen diffuses faster than chlorine. We were solving this question. So what is the answer right now? Answer is that as in case of as mass of, let me take another color. Okay. As mass of nitrogen is lesser than chlorine, MR of nitrogen is equal to 28. You should give a reference as well. MR of Cl2 is equal to 71. Hence, N2 will diffuse what? Diffuse faster. Okay. Then there is another question. Explain why the nitrogen diffuses faster at higher temperature. What will be the answer in this case? By increasing the temperature, comma, kinetic energy of nitrogen will increase. Hence, diffusion will increase. Clear? So this is really very, very simple, but a student should know how to implement this knowledge on these questions. Okay, so this was the story of this page, and now we are on the next page. Oh, great. So there are two MCQs over there. Remember this thing, guys. MCQs seems to be a simpler paper, but it is the most trickiest and it is the most difficult paper, you may say. So it is difficult to score a good grade due to MCQ. Okay, ATP and theory are the papers in which a student can identify what will be the answer and what I have to write. But in MCQ, a student should have a very perfect type of knowledge. A substance is separated using paper chromatography. Using chromatography, the chromatogram is shown over there. All right. So you can see this thing, that this is a chromatogram and we can have this. Okay, so which statement is not correct? Be careful, examiner is mentioning not sometimes. So please be aware. Sometimes students are selecting the opposite option. P has a higher RF value than Q. Yes, P has a higher RF value than Q because P has traveled longer distance. Longer is the distance, higher is the distance traveled, higher will be the RF value. So which one of the PQR has the highest RF value? P has the highest RF value as it has traveled the longest distance. R has the shortest RF value. Why? Because R has traveled the shortest distance. PQ, and so this is not the this is correct, but this is not correct. Okay, so this is not the option. P, Q, and R all are soluble in solvent. Yes, definitely they all are soluble in solvent. That's why they have traveled a smaller distance or a longer distance. If they are insoluble, they would not have traveled any distance. So that's why they are separated. They have traveled a distance. It is an evidence that all of them are soluble. Okay. Then R is the most soluble substance. No, this is wrong. R is the least soluble. Okay, it is the least soluble. Why it is so? Because it has traveled the shortest distance. The RF value of P is less than 1. No doubt it is correct. RF values are always lesser than 1. Okay, because we are dividing smaller distance with a larger distance. Smaller distance is at the top, whereas larger distance is at the bottom. So as smaller value is divided by the larger value, that's why the answer is always lesser than 1. So what is the right option for this? R is the most soluble substance. Yes, it is the right option. Why? Because R is the least soluble. Okay. The chromatogram for an unknown dye is shown. We can see the next question. This is question number 63 over there. Okay. The chromatogram of an unknown dye is shown over there. We can see this is the solvent front at the top, and 12 centimeter is the distance which is traveled by the solvent. We can see, and 9 centimeter is the distance which is traveled by the water by the point by this unknown. Whereas 15 centimeter is the total length of the paper, and paper is this is the point 2 centimeter is this distance. Okay, what is the RF value of the dye? So what is the RF value of the dye? It is 9 divided by 12. Okay, 9 divided by 12 is the answer for this. Okay, it is the distance traveled by the dye divided by the distance traveled by the solvent. So we have nothing to do with this 2 and 15. Okay, we have to just look into the line, the start line. So this line is called as the start line. Let me tell it to you very clearly. This is called start line. So we have to look into the distances of both the solvent and the spot from the start line. Okay, so this will be 9 divided by 12. You may divide it and get the answer. 9 centimeter divided by 12 centimeter. There will be no unit. You can see that there are no units, and I have mentioned in a previous video that in case of RF, there will be no unit, as centimeter is divided by centimeter. So there will be no unit in that case. Okay. Okay, all right. So then there is another question over there. Four different food colorings are analyzed using chromatography. The results are shown on the chromatogram. The diagram is not drawn to scale. All right. Which food coloring contains a component with an RF value of 0.3? All right. So we have to find out that which food coloring contains a component with an RF value of 0.3. So it means that for A, we can see this thing that it is, let's see, it is the distance traveled by, this is the distance traveled by the solvent, very clear. So this is the distance in the center. Let me draw it more in the center. So this is the distance in the center, and this is the distance traveled by A, all right, and this is the distance traveled by B, and this is the distance traveled by C, and this is the distance traveled by D. Okay, so you are going to take the distance of A divided by solvent, distance of B divided by solvent, distance of C divided by solvent, and distance of D divided by solvent. All right. So we can see this thing that the spot of A, B, C, D all will be there, and there are different types of the spots. So you can measure all these separately and can divide them by distance of solvent. As a result, the value 0.3 will be the right option. Okay. Then there is another question. Substance Q was investigated using chromatography. The chromatogram is shown. The diagram is not drawn to scale. Okay. So what is the point over there? What is the RF value of Q? Okay. So this is the distance traveled by 88 millimeter. So it means that these are the units in millimeter. There is no need to measure this. So you can take your own ruler, and it has the centimeter thing in it. Okay. So this is the distance traveled by Q. Okay, you can take it, you can measure it with the help of a ruler, and this is the distance calculated through this. You can do this. This is the distance. This is the distance by solvent, and this is the distance by Q. Okay, so it is the distance traveled by Q divided by the distance traveled by solvent. So in this way, you are going to calculate the answer for the RF value. Always we have practiced this in the same way. Then there is another question of paper chromatography. Okay, let's see what is that. Chromatography is carried out on a mixture of three substances. The chromatogram is sprayed with a lubricating agent. The results are shown. Okay, the baseline is there and the solvent front is there. What are the possible reason why the chromatogram shows only two spots? One of the substance in the mixture is insoluble in the solvent. Possibility is there. That's why it has not traveled. The lubricating agent did not react with one of the substance in the mixture. That's why it has not given a color. Remember this thing that lubricating agent is a chemical which is reacting with a colorless chemical to change it into a colored spot. Okay. So, for example, this is a spot and it is definitely made up of a chemical and it is colorless. So, when it is reacting with lubricating agent, the product of the two, the result of the two, the reaction result is colored. So, hence, in this way, we can say that lubricating agent has shifted the colorless spots into the colored spot. Two of the substances in the mixture have the same RF value. This can be also one of the option as well. That's why they have the same thing. Okay. So then they say as it is a mixture, so it means it is not possible that they are insoluble in the solvent. They must be soluble. That's why the whole mixture is there. The RF value of the one of the substances too small that it has not traveled. You may say no, it is not the option. If it has traveled a very small distance, even then it will be shown over there. Okay. So what can be the thing? The two of the substances in the mixture have the same RF value, or you may say this thing that lubricating agent did not react with one of the substance in the mixture. So 2 and 3 can be the right option. Okay. So if they are saying that the mixture is insoluble in the solvent, then we cannot take such type of a solvent for that separation. Okay. Remember this thing that the solvent which is selected for the separation is definitely that in which the whole mixture is soluble, either water or alcohol. Then there is another question. A mixture of colorless amino acids is separated using chromatography. The solvent used is propanol. Okay, propanol is an alcohol. So the mixture of colorless amino acids. Okay, amino acids are the building blocks for proteins, and protein is a building block in our body. Okay, so remember this thing that amino acids are combining with each other to make proteins. So which row describes the chromatogram is sprayed with the locating agent? Okay, which row describes the purpose of the propanol and locating agent? So propanol is a solvent to so that the components may get dissolved into that, whereas locating agent is to shift the colorless spots into colored spot. To prevent the amino acids moving further, no. To make the individual amino acid visible, yes. To prevent the amino acids moving further, no. To make the individual amino acids, yes. So we are going to check either B or D. To make the amino acids up the chromatography paper, okay. To prevent the amino acids moving too far, no. B is the right option, so that the amino acids may start traveling on the chromatography paper. So that's why chromatogram is called the chromatography paper. That's why propanol, the alcohol, is used as a solvent. Okay. Then there is another question. A mixture contains salt, sand, and sulfur. Salt, okay, any salt, sand, and sulfur. What can be the salt? The salt can be the NaCl. One of the example of the salt is NaCl. It can be sand as well. What is the formula of sand? It is SiO2 called silicon oxide, and sulfur is this. Salt dissolves in water but not in xylene. All right. Sulfur dissolves in xylene but not in water. So what is xylene? It is a compound. Sand does not dissolve in water or xylene. Okay, so it is in water, whereas this not in anyone, whereas sulfur in xylene. Okay, so then what is the order of the processes used to separate the salt and sand and the sulfur from the mixture? Okay, so if we are adding water, what will happen? Only sodium chloride will dissolve and the remaining two will be not. Okay, and then we are going to filter, for example, okay, add xylene to filter and to the filtrate, no, not to the filtrate, to the residue. Okay, add water, filter, add xylene to the residue and filter. B is the right option. Okay, look at here, I'm going to explain this. Okay, so for example, we have this complete mixture, okay, and then we are going to add water in it. As a result, only sodium chloride will dissolve, whereas SiO2 and sulfur both will not dissolve. Okay, we are going to pass this mixture through a filter paper, and here is the residue. The top is residue. So here the first option is wrong, because they are saying add xylene to the filtrate, so this is wrong. Okay, so this bottom one is called as filtrate. So now what we have to do, we have to add this xylene to the residue. So here we are adding xylene. Okay. As a result, what is there in the residue here? It is sulfur plus SiO2. Okay. So only xylene will react with sulfur, whereas SiO2 will remain obtained as a residue again. Okay, so what is the residue number one? It will be sulfur and silicon oxide. What is the residue number two? It is only silicon oxide. What is the filtrate number one? Sodium chloride solution. What is the filtrate number two? It is the sulfur solution. Okay, so we have to add water. First of all, B option I'm telling, we have to add water. It will dissolve sodium chloride. We will filter it. Sodium chloride will be obtained as a solution, as a filtrate, and then xylene will be added to residue, because residue is containing sulfur and silicon oxide, and then filter again, because now xylene will dissolve sulfur and only silicon oxide will be remain at the top. Okay, so that's why B is the right option. Okay, then is the chromatogram obtained using four substances. J, K, L, M is shown. Okay, this, which substance about M, which statement about M is correct? Okay, let's read M. Okay, so M is divided into three components, this, and this, whereas this J, K, L, and M. Okay, this L, K, and L, J, K, and L are divided into, are converting themselves into single spot, whereas M is a mixture, so that's why it is converting itself into more than one spot. So what we can say, it is a mixture of J and K only. Let's check. It is containing J, yes. It is containing K, yes. It is not containing L. So it is a mixture of J and K only. Okay, let's see. It is a pure substance. No, it's a mixture. It is a mixture of J, K, and L. No, L is not present here. It is a mixture of J, K, and an unknown substance, because we can see this thing that it is containing, one of the line is matching with J, whereas the other line is matching with K, but the third spot is the unknown. Okay, it is not matching with anyone. So that's why D is the right option. Be careful while solving these questions. Okay. Then there is another question. A chromatogram of a single substance T is shown. All right. So which substance, which measurements are used to find out the RF value of T? Okay. So it is 4, because this is the distance traveled by the spot. Okay. So it is number 4. So it is can be either B or D. And then the distance traveled by the solvent. So this will be number 3. So remember this thing, we are always taking baseline as the standard. From this we are going to start. So 3 and 4. D is the right option for this. Okay. And then this is the next question. Paper chromatography is used to separate four different colored inks, W, X, Y, and Z, and an unknown ink T. The chromatogram is shown. Which inks are present in T? All right. So we are going to check T. One spot is matching with W, with the Y and Z. Okay. And then the other spot, the second spot of T is matching with W. The third spot of T is matching with W and X. So which inks are present in T? So we have to check this, which inks are present in T. Remember this thing, that which has all the spots soluble in that. You can see this thing that Z is converting itself into one more spot, and this is not present in T, whereas X is also converting itself into one more spot, which is also not present in T. So W is converting itself into two spots. Both of the spots are matching with T, and Y is converting itself into only one spot, which is matching with T. So W and Y is the answer. I am mentioning here W and Y is the answer for this question. W and Y is the right answer for this question, because no doubt one of the spot of Z, whereas the one of the spot of X are also present in T, but the other spots of Z and X are not matching with T. That's why Z and X are not present in T. All right. Then there is another question. It's a big question, but it is a simple question, so just pay perfect attention. Okay. A chromatography experiment is carried out to analyze the pigment present in four different types of leaves. Okay, the student carrying out the experiment forgot to complete his table of results. Okay, which is shown. So plant leaf are maple, laurel, lime, and ash. Okay, number of pigments identified. So maple F233. So color of identified pigments: green, yellow, green, yellow, green, yellow, orange, green, yellow, orange. Distance traveled by the solvent front. Okay, so in maple 3.7, laurel is G, whereas lime is 3.5, and this is also 3.5. Distance traveled by each pigment: 3.1. So green is here 2.5, yellow is 2.5. So green is more soluble in which maple, whereas yellow is more soluble in maple as well. Green is this is 2.9, this is 3, 2.7, 2.8, 3, 2.7. The distance which has the one which has traveled greater distance is more soluble. RF value is 0.81, 0.83. Greater is the RF value, higher is the solubility. And this is yellow, this is H. Okay. Which row identifies the values of F, G, and H? Okay, so we have to look into this. F, G, and H. All right. So this is F, and this is G, and this is H. All right. Let's check what it is happening. Okay. So which row identifies the value F, G, and H? So F is can be 2, 3, or 2. All right. You can see this thing that 3 is converting itself into green, yellow, and orange. So again, green, yellow, and orange. So it is green and yellow, so it means that F is 2. Okay, F is 2. So it can be either A or it can be C. All right. Now come towards G. Okay. Distance traveled by the solvent can be what? It is with 3 and 3, it is 3.5 and 3.5. Whereas with 2, it is the distance should be 3.7. So it should be 3.7. Or we can see this thing that G is between the two or something like that. So you can see it can be either 3.2 here, 3.2 here. So we have to select the same. This is G is the same. Okay. Then we have to look into the yellow, yellow, the color yellow. Okay. So you can see it is 3 here divided by 3.5. 3 divided by 3.5. It can be either 0.8 or 0.86. You have to divide 3 by 3.5. So the answer will be 0.86. It is C option, guys. It is C option. Okay. Because 0.86, this 3 divided by 3.5 is 0.86. Okay. You can see here 3 divided by 3.5 is 0.86. Okay. Now we can tell, I'm repeating this question. This question has lots of data, but it was not very difficult to interpret. So we have interpreted F. How we have interpreted F? Because we have seen that 3 and 3 for lime and ash are converting themselves into green, yellow, orange, green, yellow, orange. Whereas 2 is converting itself for laurel in green and yellow, but maple in F is converting itself in green and yellow as well. So it means that the number of pigments identified in maple are also 2, because green and yellow are the two colors. Okay. And then distance traveled by solvent is 3.2, 3.2 in both A and C. So we can select either A or C. All right. So A and C are matching for F and G options. Okay, done. The point is for H. H is 0.8, whereas H is 0.86. We have seen that H is yellow. We have seen the color of yellow, and the distance traveled by yellow is 3, whereas the RF value is calculated by dividing 3 by 3.5. So it is the distance traveled by substance divided by the distance traveled by a solvent. So it is 3 divided by 3.5, 0.86 is the answer. C is the right option. Then, which process is used to separate oxygen from liquid air? I have told you very clearly while teaching you the topic of fractional distillation that it has two industrial applications. One of them is to separate the fractions of air from each other, whereas the other is to separate the fractions of petroleum from each other. So it is fractional distillation, the very correct answer. Which statement about paper chromatography is correct? A solvent is needed to dissolve paper? No, not to dissolve paper. Paper chromatography separates the mixture of solvents. Okay, let's see. The solvent should cover the baseline. No, baseline should never be covered with this solvent. The baseline should be drawn in the pencil. Yes. Paper chromatography separates the mixture of solvents, not the solvents. The spots which we have placed on the baseline were separated with the help of the paper chromatography. Solvent is water or alcohol. Paper chromatography is not used to separate the mixture of solvents like water and alcohol. Okay, water and alcohol can be separated from each other by using fractional distillation. Baseline should be drawn in pencil, because we know this thing that if we are going to draw it with pen, as a result of that, ink being dissolved in solvent will affect the results. All right. So we have solved few of the questions in this session as well. I am going to make another video related to these past papers. All the best to all of you.